Alright, so now we're talking about domain and range of continuous graphs. So, for domain, once again, remember domain is our input, it's our x's. You're going to scan your pencil left to right along the x-axis. For range, remember this is our outputs, our y's. You're going to scan your pencil top to bottom along the y-axis. So when we look at number 1, if you see these arrows, it should remind you that this line goes on and on and on forever in opposite directions. So when we're scanning our domain, it doesn't technically start right here because this line goes on forever. This line goes on forever. So when we're trying to talk about our domain, what does it mean if it goes on forever? So that means it goes on to negative infinity this way and then to infinity this way. So that means for our domain, it includes all real numbers. Real numbers. So all real numbers. Our range, however, it goes all the way up. However, it has a stopping point. So you have to identify where exactly does it stop. So it's everything above, but once you get down right here to negative 2, it stops. Does it include negative 2? Yes, but it doesn't include anything less. So this is when we start talking about our inequalities. So if I want to represent that our range, which our range is y, can be anything greater than or equal to negative 2, you would have to include your greater than or equal to symbol than negative 2. So that's telling me that my domain is all real numbers because the arrows go on forever. However, it stops at negative 2. So let's look at number 2. So number 2 is the circle. So there's no arrows. So that means it doesn't go on forever and for infinity. So what you notice is when you go left to right, it starts right here at negative 3, and then it stops at 3. So that means it goes from negative 3 to 3. But we want to know what numbers or what x values it includes. So you ask yourself, can it equal negative 3? Yes. Then you say, well, it needs to be values greater than negative 3 or equal to. Here, it can include 3 or any numbers less than 3. So that tells you that your domain falls within this specific range. Then we go to range. With range, we're dealing with y's. So you start at the top and you hit 3 here. To the bottom, you hit negative 3 here. So once again, it falls within this range. So you'd write it the same. You'd have your negative 3, your positive 3. You're trying to identify what all can be y. Well, y can be negative 3 or greater than negative 3, and y could equal positive 3 or less than 3. This is why our inequalities comes back to use now. Alright, domain and range. So our x values. Well, now we have arrows again. So if I go this way, it goes forever this direction and forever this direction. So to the left, it goes to negative infinity. To the right, it goes to infinity. So if it goes on and on and on forever, then you're going to say that it includes all real numbers. All real numbers. Then we look going from top to bottom. So if you think about this line going on and on forever, it's always going to hit somewhere on the y-axis, no matter if it's on top or to the bottom. So it goes to infinity and negative infinity. If it goes all directions, then it is all real numbers. Let's look at this one. So for our domain, we have arrows again, so it goes in each direction for infinity. So that'll be all real numbers. Pretend that's just one L. all real numbers. But when we go from top to bottom, it doesn't include anything up here. It has a specific starting point. Then it goes forever downwards, but it has a specific point at the top it reaches, and it can't go past it. So you look and you say it's 1, 2, 3, 4. So we're comparing y and 4. And we have to ask ourselves, can our range hit 4? Yes, it can be equal to. Can it be greater than? No. Can it be less than? Yes. Pause the video and try 5 and 6 on your own. Once you think you have it, start the video again. Alright, have you stopped it and tried it? So number 5. We're going left or right. Well, we hit a wall here. Nothing to the left of this point matters. And then we hit a wall here, nothing to the right matters. So since it doesn't go on forever, it's not going to be all real numbers. It has a definite start and a definite stop. So it starts at -1, and it stops at 1, 2, 3, 4, 5. And so our x values will fall somewhere between here. So you say, well, can it hit -1? Yes, it could be equal to -1, or it needs to be larger than -1. It can equal 5, or it can be less than 5. Then our range, once again, it has a definite start and a definite stop. So we have 1, 2, 3, and 1, 2, -3. So when we compare this, we have -3 and 3, and y falls between. Y can equal -3 or numbers larger. Y can equal 3 or numbers smaller. So that gives us our range of what's actually included. On number 6, we have arrows again. So going left to right with our arrows is going to include all real numbers. And then our range, we're going to start at the top. We're going to go down. And it's going to go up forever and down forever. So this also includes all real numbers. So let's look at number 7, 8, 9, and 10. I'm going to turn off the alarm. All right, 7, 8, 9, and 10. So for number 7, although this is a crazy looking graph, we still follow the same rules. We start left and go to the right. So it goes on forever this direction. It'll keep going up and down whenever. There'll be -infinity all the way to infinity. So my domain is considered all real numbers. Then we do the top to bottom. Well, once we get to the top area, it hits this line, but it doesn't hit anything further. It stops right here. And then, when we go down, it stops right here. Because really, this should be going like this to show that it's going up and down in that repeating pattern. So you have to see where it hits. So we hit 1, 2. So at +2, we have 1, 2, 3 at -3. So we have -3 and 2, and we're always putting these smallest to largest. And our y can equal -3 because it hits the line, or anything larger. And our y could hit 2, or anything smaller than 2. On number 8, when we go left to right, well, when we come from the left, nothing here is included. Nothing over here. It doesn't start till we get to this point, which is -1. So that means when I compare my x and my -1, it can equal -1, or it can be larger than -1. It can never include numbers smaller than -1. Then, when we look, our arrows will go forever in this direction and forever in this direction. They'll keep going on forever. So, if they go on forever, it's considered all real numbers. Alright, number 9 and number 10. So these are just normal lines. So we have a vertical line. So when we go from the left to the right and we hit this, all of my points of this line fall on positive 2. So for our domain for this one, we just say x equals 2. And it goes forever to infinity positive and negative infinity the other way. So our range is going to be all real numbers. For our horizontal line, we start on the left, we go to the right. Well, it goes forever to the negative infinity and forever to infinity. So our domain is all real numbers. But when you look, going top to bottom, all of my points will hit on this same line. You'll never get more, you'll never get less. So that's 1, 2, 3, negative 4. So that means that y will equal negative 4 for every single point that I get.